Okay, so today we're looking at angles of elevation and depression. So an angle of elevation is an angle that is formed by a horizontal line and a line of sight to an object above the horizontal line. Which means that our angle of depression is an angle that is formed by a horizontal line and a line of sight to an object below the horizontal line. Okay, so what this means is if, in this picture, if we have a horizontal line that starts at this little person's eyesight, and she's looking at this hang glider over here, the angle of elevation is because our horizontal line is at her eyesight, and the object that she's looking at is above her. Okay, so that means that it's forming an angle when she's looking up. The angle of depression from the hang glider to the person, because the eyesight is at that hang glider, he's looking down at this person down here, which means it's an angle of depression. So one thing I want you to notice is that the angle of elevation is congruent to the angle of depression because they are alternate interior angles. Okay, so remember, if we have an angle, if we have two parallel lines and a transversal, those two angles are going to be congruent. Okay, so if we move on to the next page, the first thing we want to do is just figure out which are angles of elevation and which are angles of depression. So if we start up here at this bird, we notice that the horizontal line is dotted and the angle that it's forming for angle 1 goes down, which means that this is an angle of depression because it's going downwards. Okay? And if we're looking at angle 4, the sight line is about at the beginning or at the base of this mountain. And if there's a person at the bottom of this mountain, they're looking up at this person in the hot air balloon, which means that it is an angle of elevation. Okay, let's go ahead and try to figure out angles 2 and 3. They both have the same sight line. Angle 2 has that angle moving up, so that is going to be an angle of elevation. And angle 3 is going to be an angle of depression because that angle is being formed by a sight moving down. Angle of depression. Okay. So if we move on, we're going to use the angle of elevation and angle of depression. Okay. So right now, we're standing about 53 feet away from this wind turbine. Okay. And our angle of elevation is going to be this 56.5 angle. So if my eye level is about 5.5 feet off the ground, okay, we want to figure out how tall the turbine is from the ground all the way up to its hub. So we need to find this X right here, and then we're going to add that 5.5 to it. So if we have our angle, we have an opposite side, and we have an adjacent side. We are going to use tangent because we're looking at SOHCAHTOA. TOA has our opposite and adjacent. So we are going to use tangent of our angle, which is 56.5, equals opposite, which is our X, over our adjacent, which is that 53. Okay? To solve for this, we are going to multiply both sides by 53. That leaves us with 53 tangent of 56.5 equals X, which when we put that into our calculator gives us about 80.07. Okay, and what we want to do is we are going to take that 80, I'm just going to round it to 80. We're going to take that 80 plus the 5.5 because we want to know from the ground up how long this is. So when we do that, that gives us 85.5 feet. So that wind turbine is about 85.5 feet tall. Okay. So go ahead and start working on the got it problem. Figure out what it's asking you to find. So if you sight a rock climber, so your rock climber's up here, you're right here, and they're at an angle of elevation of about 32 degrees, and we've got our eye level is 6 feet above the ground. So we're about 1,000 feet away from the cliff, and we want to know what the height of the rock climber from the ground is. So we need to find this side right here. Remember that this is an opposite and adjacent sides, which means we're going to use tangent. So we're going to have tangent of our angle, which is 32, equals the opposite, which is X, over our adjacent, which is 1,000. Okay, so to solve for that, we're going to multiply both sides by 1,000 to get X by itself, which leaves us with 1,000 tangent of 32 equals X. So our X, when we put this into our calculator, is going to equal about 624.9. So remember, our last step is to figure out, we have to figure out the height of the mountain in general. So we're going to do that 624.9 plus the 6 feet, which equals 630.9 feet. Okay, so that's going to be our answer. Okay, last page, we're going to look at angle of depression. It's the same type of thing. So if we're approaching a runway in Oklahoma, the pilot has to begin a 3-degree descent. So our degree is right there. Starting from a height of about 2,714 feet above sea level. Okay, so if the airport is 1,007 feet above sea level, we want to figure out what this is. Okay, so from here, you're going to take this 2,714 minus that 1,007 to find this side right here. So when we do that, that leaves us with 1,707 feet. So that's what we're going to put right here. Okay, so it wants to know how far away from the runway is the airplane when it starts its approach. So we want to find this X right here. So right now we have an opposite side and we have a hypotenuse. Okay, So if we're using opposite and hypotenuse, when we use SOHCAHTOA, we're going to use our sine. So we're going to have the sine of 3 equals our opposite, which is that 1707 over our hypotenuse, which is x. So to solve for this, we're going to multiply both sides by x, which leaves us with x sine of 3 equals 1707. And now we're going to divide by that sine of 3. Okay, that's going to leave us with x equals 1707 divided by the sine of 3. So when you put that into your calculator, it gives you about 32,616.2 feet. Okay, so that's going to be our answer in feet. It's actually asking us to the nearest tenth of a mile. So what we want to do is make it into a mile. So if we have this 32,616.2 feet, there are 5,280 feet in 1 mile. Remember our train tracks. So if we divide 32,616.2 feet divided by 5,280 feet, that leaves us with about 6.2 miles. Okay, so the airplane is about 6.2 miles away from the airport when it starts its descent. Okay, and our last question. So we have an airplane that spots a life raft at an angle of depression. So if we have an airplane up here, I'm just going to draw it out. We've got this horizontal line, and it spots a raft. Make it just a circular raft. Okay. It spots a raft at a 26-degree angle of depression. So it says the altitude, so the height from the life raft, is about 3 kilometers. Okay? And we are looking for the horizontal distance from the life raft. So horizontal distance means we're looking at this side right here. Okay? So what we're going to do is we're going to circle our angle, and we're going to figure out what sides we have. So we have an opposite and we have an adjacent side. So what we're going to do is we're going to use our tangent. So we're going to have tangent of our angle, which is 26, equals our opposite, which is 3, over our adjacent, which is x. So we're going to multiply both sides by x, which leaves us with x tangent of 26 equals 3. And we're going to divide both sides by tangent of 26. That leaves us with x equals 3 tangent of 26. When we put that into our calculator, it gives us about 6.2 kilometers. Okay? And that should be it.